Hello and welcome to all to this lecture series on fluid mechanics. This is lecture 5, buoyancy and flotation. So let us begin. First of all, we need to know what is the term buoyancy. Okay. See, you might have noticed a important phenomena that when there is any body, okay, that is immersed completely or partially in a fluid, it experiences some loss in its weight. Okay, suppose you have a spring balance, you have a body suspended on a spring balance and in air, and you note some reading on the spring balance, and when that same body with that is suspended by that same spring balance, that is immersed in a fluid completely or partially, so the reading on that same spring balance of that same body will be somewhat lesser than the previous case. Have you ever thought of why it is so? Okay, and what is the physics behind it? Okay, so that the physics behind it, that it is being acted upon by some kind of a force in the opposite to the weight. Okay, that is decreasing the magnitude of that weight that is being shown by that spring balance. Okay, so whenever a body is immersed completely or partially in a fluid, it is subjected to an upward force, okay, and which tends to lift the body. So when that force acts in the opposite direction to the weight, so due to that force only, there is some decrease or some reduction in the reading of that spring balance or the weight of the body. Okay, the upward force acts in opposition to the force of gravity, as I have already told you that the weight of the body, that is due to the force of the gravity that works in the vertically downward direction, and this buoyancy force acts in the upward direction. Okay, and since the buoyancy force acts in opposition to the gravity, that is why there is apparent loss in the weight of the body, okay, when it is immersed in a fluid. And moreover, important point is that buoyancy force is independent of the distance of the body from the free liquid surface. Means when the body is immersed in a fluid, the body will be somewhat below the free liquid surface. Okay, so the distance of the body from the free liquid surface does not influence the buoyancy force, and also the density of the body does not influence the buoyancy force. Means whatever be the density of the body, the buoyancy force acting on that body will be same. Okay, but it depends upon the density of the fluid in which the body is immersed. Okay, please make a note of it that the density of the body does not influence the buoyancy force, but the density of the fluid in which the body is immersed, that affects the buoyancy force. Okay, then there is a center of buoyancy. It is the point of application of the buoyant force on the body. Okay, this is the point of application. This is the point of application of the buoyant force on the body. Okay, and it coincides with the center of gravity of the dispersed fluid. This is very important, that it coincides with the density, with the center of gravity, of the displaced fluid. Okay, and for a homogeneous body which is completely submerged under the fluid. Okay, what is a homogeneous body? Which is having same characteristic within the body, or the same density and all those, which is uniform throughout its dimensions, that is a homogeneous body. And when that homogeneous body is completely submerged under the fluid, then the center of buoyancy will coincide with the center of gravity of the body. Okay, when the completely submerged, then the center of buoyancy will coincide with the center of gravity of the body. Okay, then we have one important principle in this, that is known as the Archimedes principle. What is it? It gives the magnitude of the buoyant force exerted upon the body. It is for finding the magnitude of buoyant force. Okay, and what does this principle state? This states that the buoyant force exerted upon the body is equal to the weight of the liquid displaced by the immersed portion of the body. So this is important, that it is equal to the weight of the liquid displaced. Okay, weight of the liquid displaced. The buoyant force is not equal to the weight of the body. Okay, it is equal to the weight of the liquid displaced by the immersed portion, of the body. Okay, this is important. Please make a note of it. Archimedes principle, very important. Okay, then what is the cause of force of buoyancy? Why this force of buoyancy exists? Okay, this force of buoyancy comes into existence because of the varying pressure intensity on the different portion of the body which is immersed in a fluid. Because when there is any body, it has got some dimensions, okay, and the pressure intensity is different. The pressure decreases with height. As we go down into the liquid surface, we know that the pressure intensity decreases. So on the upper portion the pressure will be less, and on the bottom portion the pressure will be down, means pressure will be more. So more pressure means more force. So the force exerted on the bottom surface will be more, and the force exerted on the upper surface will be less. So due to this difference in the force, there exists a net upward force, and that net upward force is the force of buoyancy. Okay, that is because of the varying pressure intensity. Please make a note of this, the cause of force of buoyancy. Okay, then we have some different cases. When the first case is when the body is completely submerged under the fluid. Okay, when the body is completely submerged under a fluid, means only one fluid. Okay, then there are some assumptions what we follow, that we have an arbitrary shaped body of volume V. Okay, this is like this is something looking like an ellipse, so you can take it any body. Okay, this is an of having the volume V, and the static mass of the fluid of a specific weight omega. The specific weight of this fluid is omega, and the elementary vertical prism Mn. This is the vertical prism Mn. Okay, and the resultant force acting on this elementary prism Mn will be P2 dA minus P1 dA. Okay, in the upward direction you can see that this force will be P2 dA from this surface, and this force will be P1 dA on this. So P2 dA minus P1 dA will be in the upward direction. Okay, and P you can write as omega H2 and omega H1 dA. Okay, this was omega H2 minus omega H1 dA, and omega Y dA equal to omega dV, where this Y dA is dV, and this is the volume of the prism. Okay, and the total buoyancy force exerted by the body, because this is only for this prism Mn. Okay, then for the total force exerted on the body, you have to integrate this. Okay, you have to integrate it over the whole volume. So we get that Fb, that is the buoyancy force, is equal to omega into V, where V is the volume displaced by the body. Please make a note of this, that this V is not always the total volume of the body. Okay, this is the volume displaced, volume of the fluid displaced by the body. Okay, in the case when the body is completely submerged, in that case it can become the total volume of the body, but it is not always the complete volume, but it is the volume of the liquid displaced by the body. Okay, please make a note of it, this is very important. Okay, then when the body is completely immersed under fluids and it is at the interface of two fluids. Okay, means in the earlier case it was only one fluid, now it is in two fluids. Okay, this is one fluid and this is another fluid. Okay, one fluid is having we follow the same assumptions, that arbitrary shaped body of volume V and the static mass of the fluids of specific weights omega 1 and omega 2. This is omega 1, this is omega 2, and the elementary prism Mn. Okay, in this case also the resultant pressure force on the elementary prism is P2 dA minus P1 dA in the upward direction, and when we change this P2 in the terms of omega 1 H1 plus Y1 and omega 2 Y2 minus omega 1 H1 into dA, and we get these terms, this H omega 1 H1 and this gets cancelled. This is omega 1 Y1 plus omega 2 Y2, this is omega 1 Y1 dA plus omega 2 Y2 dA, omega 1 dV1 plus omega 2 dV2, and the total buoyancy force we will get by integrating this and this term over the complete volume. Okay, complete immersed volume I should say. Then omega 1 dV1 omega 2 dV2, or Fb, is equal to omega 1 V1 plus omega 2 V2, or which is also equal to Fb1 and Fb2. And please again make a note of it, that V1 and V2 are the volume displaced by the body. Okay, displaced by the body of the upper and lower liquids respectively. These are, I am again emphasizing on this point, that V1 and V2 are not the complete volume of the body. Okay, these are the volume of the liquid displaced by the body. Okay, So please make a note of it. This is very important, and this kind of problem has many times appeared in many exams. Okay, that there are two fluids and the body is immersed in it, and then they ask that what fraction of the total volume of the body is in the fluid two, or what part of the fraction of the volume of the body is in fluid 1. Okay, these kind of questions, when you will solve the problems, you can already see, you can see that this kind of problem has arrived many times in the exams. Okay, then moving forward, the third case, if omega 1 is very much less than omega 2, then the body is floating in the fluid. That means that the above, see, if you have this kind of a case, you have a water with omega 2 and air of omega 1, and omega 1 of air, that is the specific weight of air, is very much less than the specific weight of water. So in this case, you can say that the body is floating in the liquid, in this liquid. So in that case, the FB, that is the buoyancy force, is equal to omega 2 V2, and V2 is the volume of the liquid displaced by the immersed portion of the body. Okay, then we have something known as the principle of flotation. What is it? Two important conditions. First of all is that the weight of the body floating in a fluid should be equal to the buoyant force, which is equal to the weight of the fluid displaced by the body. Means that the body will only float when this condition is satisfied, when the weight of the body is equal to the buoyant force. Okay, and the buoyant force is equal to the weight of the fluid displaced by the body. This is the weight of the body, is the complete weight of the body, or the total weight of the body, but the buoyant force is the weight of the fluid displaced by the body. Okay, and second important point is that the line of action of the weight of the body and the buoyant force must lie along the same vertical line, so that their moment about any axis is 0. Okay, so these both the forces must act along the same vertical line, that the weight is acting downwards and the buoyancy force is acting upwards, but they must act along the same line so that their moment about any axis is 0. Okay, then let us move ahead. Then we have one important term that is known as metacenter. What is it? See, it is defined as the point about which the body starts oscillating when tilted by a small angle. First of all, let me tell you, this metacenter concept comes when the body is partially immersed in any fluid. Okay, suppose this is a free liquid surface and this is a body originally at rest. Okay, this is the center of gravity, the weight is acting downward, and this is the center of buoyancy, it is the force, the buoyancy force is acting upwards. Okay, but when we will displace this body by a small angle theta, okay, this is the small angle theta by which the body is displaced. So what happens, some portion of this body will get above the water surface from this side, and some extra portion will get immersed from this side. Okay, so what will happen, this center of buoyancy will tend to shift towards this. Okay, tend to shift towards this side, and suppose this B1 is the new center of buoyancy, and you know that the force of buoyancy always acts in the upward direction, vertical upward direction. So this vertical upward direction, this force and this line of action will intersect this original axis at some point, and this point is only known as the metacenter. So this is only what I have written here, that it can also be defined as the point of intersection of the original vertical axis. This is the original vertical axis, you can see this is the original vertical axis. Okay, and passing through B and G, that is the center of buoyancy and the center of gravity, and the new vertical axis passing through the new center of buoyancy. Okay, this is the new vertical axis, this is passing through the new center of buoyancy. So this is the point of intersection. Okay, then what is a metacentric height? It is the distance between the metacenter M and the center of gravity. This is the center of gravity and this is the metacenter. The distance between this, that is GM, is known as the metacentric height. Okay, then what is metacentric radius? It is the distance between the metacenter M and the center of buoyancy. Okay, that BM. Center, the distance between M and G is metacentric height, and the distance between M and B is the metacentric radius. BM is known as the metacentric radius. Okay, and for a small theta, the locus of successive centers of buoyancy approximates a circular arc with metacenter M as center and BM as radius. That is why this BM is known as the metacentric radius. Okay, and what is the magnitude of this? The magnitude is I by V. I by V. And what is this I? This I is the second moment of area of the cross-sectional area of the object about the longitudinal axis of the liquid surface of the at the liquid surface. Okay, about the longitudinal axis. Two important points here. First important point is that it is about the longitudinal axis, and second important point is it is at the liquid surface. Okay, and what is this V? This V is the volume of the liquid displaced by the body. This is again the same thing, that it is the volume of the liquid displaced by the body. I'm not going into the derivation. You can look for it in any standard book. This derivation is very simple. Okay, and then what is G? This is Bm minus Bg when Bm is greater than Bg, and this is equal to Bg minus Bm when this Bm is less than Bg. So if we combine these two, we will get that Gm is equal to plus minus I by V minus Bg, and I have already told you what is I and what is V. Okay, this is also very important. This is also asked in various examinations very frequently, time and again. Okay, then we will move on to the stability of the fully submerged bodies. Okay, first of all we will have fully submerged bodies, then we will move on to the floating bodies. Okay, so for the fully submerged bodies, we have for the stable equilibrium that B is below G. See, this is okay. Please make a correction out here, that this is not B is below G, this is B is above G, and this is B is below G. Okay, please make a note of it. See, first of all I will tell you what happens. See, this is the original body. If it is having the center of gravity G through which the weight is acting downwards, and this is the center of buoyancy B through which the weight of buoyancy is acting upwards, and if what happens, this is the normal resting position, and if we just tilt that body by a small angle in this direction, okay, this is the disturbing couple. So what happens, this buoyancy force will keep on acting upward, and this weight will keep on acting downward. So due to these two forces, what will happen, there will be a couple, there will constitute a restoring couple in this direction. Okay, in this direction, so that will tend to again bring the body in the original position of this. So this is known as a stable equilibrium. Okay, please make a note of that. This is B is above G. I am again telling you, please make a note of correction here, that this is B is above G. And what about the unstable equilibrium? The B is below G. If B is below G, then it is unstable equilibrium. This again happens that this force is acting upwards, this force is acting downward, and if we disturb this by providing some disturbing couple in this way, in the clockwise direction, then what happens, this force FB will act upward, this weight will act downwards, and this will constitute an overturning couple in this direction. And then what will happen, this body will turn around its position, and this G will come down and this B will come up. Then only it will become, the body will become stable. So this is an unstable kind of equilibrium in the body is overturned. Okay, overturned. And what is the neutral equilibrium? When the B coincides with G, then it is a neutral equilibrium. Then whatever be the disturbing couple you provide to the body keeps the body remains at whichever positions you tilt it. Okay, so that is the condition of neutral equilibrium, and that is the B coincides with G. Okay, let us move on forward. Then we have the stability of the floating bodies. For the stable equilibrium, we have M is above G, that is Bm is greater than Bg. See, you see that this is a body, this is the free liquid surface. You see that this is the G through which the weight is acting downward, this is B through which the buoyancy force is acting upward. So in the initial condition, this FB is equal to W. Okay, and if we tilt this body by providing this disturbing couple by an angle, small angle theta, so what will happen, again this center of buoyancy will shift towards this point, and this new center of buoyancy, the new center of the new buoyancy force FB1 will act in the upward direction. Okay, so what will happen, this is the M metacenter M. So due to these two forces, the weight downward and this FB1 upwards, there will be a restoring couple in this anti-clockwise direction, which will try to bring the body into its original position. Okay, so this is a stable equilibrium, and the magnitude of the restoring couple is W into Gm sine theta, because it will be this distance. Okay, W, because this is the distance between the two forces, so that will be give you the couple, magnitude of couple, that is W into W or FB1, because that will be same. So W into FB1 into this GM sine theta, because this is GM, so this will be GM sine theta. Okay, so this is the magnitude of the restoring couple, and this is the case of stable equilibrium. In the case of unstable equilibrium, we see that the M is below G, that BM is less than BG. You can see that, you can see here, you can see that the this BM is greater than BG. Okay, and here if you see that the BM is less than BG. Okay, that BG is greater than BM. Okay, similarly in this case also we provide a disturbing couple in this way, and if we tilt this body, so due to these two forces, what will happen, it will constitute again a couple in the clockwise direction, which will try to overturn this body. Okay, will try to completely overturn this body. So this is an unstable equilibrium, and the magnitude of the overturning couple is also equal to WGM sine theta, and this is the unstable equilibrium. When the M and G coincides, then it is again the case of neutral equilibrium, and whatever be the disturbing couple you provide to the body will remain in that position. Okay, so that is the neutral equilibrium, that M and G coincides. Okay, then we have one more important concept, that is the time period of transverse oscillations of a floating body. Okay, when the body oscillates about the longitudinal axis, okay, in the transverse direction, then the time period of oscillation is given by T is equal to 2 pi kg upon under root GGM, where this kg is the radius of gyration of the body and this GM is the metacentric height. This derivation can also be looked upon in any standard book. This is a very simple derivation. Okay, so you can look for it. And then some important terms, that the oscillation about the longitudinal axis is known as rolling, then the oscillations about the transverse axis is pitching, and the steering motion is known as yaw. And one another important concept is that if the body is safe against rolling oscillations, if the body is safe against the rolling oscillations, that means the oscillations about the longitudinal axis, then it will be also safe against the pitching oscillations. Okay, I leave you just with this statement, and I give you a suggestion to just provide me with the answer of this. Means this is a statement, however this is just a statement, it's a correct statement, it is not any question, but I just need you to tell me that how this is justified, that if the body is safe against rolling oscillations, then it will also be safe against pitching oscillations. How you can mathematically prove it? Just give me an idea in the comment section. You can just tell me that how this statement is justified. Okay, then if you will not be able to do it, I know that you all can do it, but if you won't be able to do it, then please let me know. I will provide you with the answer of this statement, the justification of this statement. Okay, then for the passenger ships, we have the GM should be less, because what is there in the case of passenger ships, the comfort is the prime concern. Okay, and for the comfort, the time period of oscillation should be very much high, because the time period of oscillation, because the frequency of oscillation is inversely proportional to the time period, and for the passenger ship where the comfort is the prime concern, the frequency should be less, and the frequency should be less means the time period should be more, and the time period should be more, you can see that GM is inversely proportional to T, and T should be more, that means the GM should be less. Okay, and for the warships where the accuracy is prime concern, in that case the GM should be a positive value and it should be a large value. If the GM is a positive and a large value, then the stability is more and accuracy is more, or the stability is more, and in warships the stability and accuracy are the prime concern. Okay, so this is all for this lecture. In the next lecture, a very important lecture, as has been demanded by some of the viewers, that next lecture would be, obviously it was the lined up lecture, that the fluid kinematics, but I will try to make that 2 lectures on that fluid kinematics, because it's a very large topic, and one lecture will become a kind of a boring kind of situation. So I will try to make 2 lectures on that fluid kinematics. So okay, so please stay tuned for that lecture on fluid kinematics and many more to come. Till then, okay, till then, keep watching, keep learning, and do provide me your comments in the comment box, your suggestions, your queries, and please like and subscribe to the videos if you find them suitable. Okay, so keep stay tuned for the next lecture. Till then, thank you. for watching this, and good day.